Ions and ionic bonding. We learned earlier that atoms are more stable if they have the same number of electrons as an inert atom. In the first two rows, or periods, of the periodic table, the stable number of electrons is either 2 or 10, equaling the number of electrons of the inert elements helium or neon in group 18. We can extend that to the third row, in which the inert element is argon with 18 electrons. Also, we learned that one way atoms achieve a stable number of electrons is by sharing electrons with another atom, so that each becomes stable. Once electrons are shared between atoms, the atoms are bound together by a covalent bond, forming a molecule. So far, the elements we studied which form covalent bonds are circled below. We extend that on the next page to period 3. Below, circled in purple, are the 16 elements in the first 3 periods which can form covalent bonds. But what about these two elements, lithium and sodium? They are the only elements which were not identified as being inert nor being able to make covalent bonds. Can they make any bonds? Beyond hydrogen, can the group 1 elements in the far left column form bonds? If so, what sort of bonds? Let's start by studying lithium. Lithium has 3 electrons. Can you see the easiest way for it to achieve a stable number of electrons, 2, 10, or 18? Discuss. If lithium loses 1 electron, it would have 2, which is the stable number represented by helium in period 1. Lithium would not become helium, since it would still have 3 protons, but it would have the same number of electrons as helium. Since it would have fewer electrons than protons, it would have a positive electrical charge, making it a positive ion, a cation. Losing an electron transforms lithium from being an atom to being a positive ion. But lithium can't just lose an electron, it has to donate it to another atom. Can you see any atoms below which could use 1 more electron to reach a stable number of electrons, 2, 10, or 18? Discuss. There are 2 atoms shown below that would reach a stable electron configuration by accepting an electron. Fluorine would go from having 9 to 10 electrons, so would match the electron configuration of neon. Chlorine would go from 17 to 18 electrons, so would match the electron configuration of argon. Group 17 elements are called the halogens. Fluorine would have 10 electrons and an electron configuration like neon. It would still have 9 protons, so it would still be fluorine. Since it would have more electrons than protons, it would have a negative charge, becoming a negative ion or an anion. Gaining an electron transforms fluorine from being an atom to being an ion. Chlorine would have 18 electrons and an electron configuration like argon. It would still have 17 protons, so it would still be chlorine. Since it would have more electrons than protons, it would have a negative charge, becoming a negative ion, an anion. Gaining an electron transforms chlorine from being an atom to being a negative ion. Group 17, called the halogens, strongly attract electrons from other atoms, since any of them can reach the electron configuration of group 18, the inert elements, by just adding 1 electron. This will be true even as you later learn about more periods or rows of the periodic table. In future courses, you'll learn about other atoms which can form ions and ionic bonds. Group 1 atoms lose an electron to an atom in group 17. Group 1 elements become stable by losing an electron, giving them the number of electrons of the inert element in the previous period. Group 17 elements become stable by gaining an electron, giving them the number of electrons of the inert element in their period.